Hello dear instructors and students, we are Team 51 and this is our project called How Hardware Works of Principle of Information Systems course. And my name is Eldar Mehmetzadeh and I'm the group leader of team. And my teammates are Ali Aliyev, Amal Hacıyev, Zeynep Aydınlı and Fatime Rizayeva. In our project we want to show how computer hardware actually works by explaining AND, OR and NOT gates. Simply, these gates are the foundation of all digital devices. So we built each gate on a breadboard using transistors, resistors, LEDs and buttons to show how they work in real life. So let's get started with the NOT gate. Firstly, we put push button and with using jumper wire, we connect it to the +5 rail. This will act as the input signal when pressed. And later we connect the 2000 ohm resistor. So the reason of connecting it, we will connect it to the base of NPN transistor. Then we are going to use another jumper wire to connect the emitter to the transistor. So we connect it to the ground minus rail of the breadboard. Then we're using some other jumper wires to make a connection with the LED. So also we are going to use 330 ohm resistor to not cause burning out of the LED. So as you can see from the video, we firstly connected to the wrong side, so then later we corrected it. So the end of the jumper wire, we're gonna connect the cathode of the LED with jumper wire, and the cathode anode side of the LED we are gonna connect to the ground. So it finished and we are gonna explain how it works. So you can see there is button is not pressed, but when it's pressed it turned on. So as you can see, when button is not pressed, the base of transistor gets no voltage, so let's turn on. When the button is pressed, the base gets voltage through the 2000 ohm resistor, so the LED's voltage drops almost to zero, so it turns off. So our another gate is OR gate. So again, it's the beginning of the OR gate. It's the same as AND gate. We're using two push buttons. We use jumper wires to make a contact with one of the leg of push buttons and to the +5 volt rail of the breadboard. Then we're using 2000 ohm resistors, for both push buttons, as you can see from the video. So it's for the connection to the base of NPN transistors. So you can see we connecting the transistors to the resistor. And the second one. So we are using jumper wire to make a connection between the emitter of NPN transistor and to the ground. And later we're using another jumper wire to make a connection between collector of the first transistor to the transistor which we are going to use for the third one. Both of the transistors collector is connected to the third transistor because it's in the meaning of the OR gate. It should be connected to different, not together. So So later we use again 2000 ohm resistor to stabilize the input. Then also we use jumper wire to make a connection to the base of the third transistor. Later we use jumper wire to make connection between emitter of NPN transistor to the ground to get electricity. Later we use another jumper wire, and this jumper wire will connect to the LED. Before connecting, we connect the cathode of the LED to the jumper wire, and using 330 ohm resistor to not causing burning out, and we connecting the anode of the LED to the ground again to get electricity. Later we realized that we missed one jumper wire. As you can see, we're searching for it, but it's again correct. So we trying to find the mistakes that we have done. Firstly, we trying to connect the button again, but later we realized that transistor emitter is not connected to the ground, so transistor cannot get voltage because of this. So we correct our mistake and connect it to the electricity, so it works. So simply the working system of OR is just when we do not press both buttons, the transistors do not get voltage, so LED doesn't turn on. But if you press one of the buttons, it's enough to get fully activated to the third transistor and LED turn on. And also when we push both buttons, the third transistor gets fully activated and LED becomes turned on.
Alright, now we're building another logic gate, the AND gate. For this one, we're going to use two push buttons as our inputs. First, connect one leg of each button to the plus 5 volt rail in our breadboard. This will give both buttons power when we press them, so in future we can check with the inputs by pressing one of them. Next, we're going to use 2 kilo ohm resistors, that's 2000 ohms each, and connect them between the other leg of each button and base pin of 2 NPN transistors. So basically, each button is controlling only one transistor. Now, grab a jumper wire and connect the collector of the first transistor to the emitter of the second transistor. This is what makes the current flow only when both are active, just like the logic of the AND gate. And take another couple of jumper wires and connect the emitters of both transistors to the ground rail on our breadboard. That completes the return path for the current, so no problems will occur in future. Next, we will add another 2K resistors. So just to stabilize the input signal, this will prevent any noise or false triggering. Let's just move it. Now we move on to the LED. Take a jumper wire from the collector of the last transistor and connect it to the cathode, like that's a short leg of the LED, and add the 330 ohm resistor right after it to limit the current and make sure the LED doesn't burn out and everything goes as expected. And finally, if the correct node was connected by us, let's see. So yes. Finally, the correct node and the long leg of the LED to the 5 volt rail by jumper wire, and it should be done. So it will behave now as needed. Now let's check and input connection. So when both buttons are not pressed, that's 0, 0, so no voltage reaches the transistors and the LED stays off. When you press only one button, it's either 0, 1 or 1, 0, so only one transistor gets power, so the current can pass through, but the end LED is still off. And finally, 1-1 is when both buttons are pushed. It means the current will flow all the way through the circuit and LED lights up.